Good morning and Jai Hind to all. Now, last some videos we discussed what is matrix and how to construct a matrix and different operations on matrices. And last symmetry transpose of a matrix, then symmetric and skew symmetrics. The last video we discussed some theorems regarding the topic symmetric and skew symmetric matrix. And then our last class we discuss how to express a matrix as a sum of symmetric and skew symmetric matrices. Now we discuss some special problems regarding the topic matrices. Okay, these are some miscellaneous questions. These are very simple questions. Okay, now we start. Our first question is special case 1. If A is equal to matrix 0 2y z 0 2y z, second row xy minus z, and third is x minus y z. Satisfy the condition A transpose into A equal to I. Then find the value of x, y and z. It's a very simple question. Okay. This is special case 1, SC1. A is equal to 0 to y z, x, y minus z and x minus y z. Satisfy the condition A transpose into A is equal to I. Then what is the value of x, y and z? Okay. Here first of all we apply the condition A transpose into A is equal to I. You already know what is A transpose here? The transpose of the given matrix 0 x 2 y minus y, then z minus z into A. What is A? 0 2 y z, then x y minus z x minus y z is equal to, you already know what is identity matrix 1 0 0 0 1 0 and 0 0 1. Now using matrix multiplication, first row, first column, 0 into 0 plus x into x plus x into x. Then first row, second column, 0 into 2y plus x into y minus x into y. Then first row, third column, 0 into z minus xz plus xz. Similarly, second row, first column, 2y into 0 plus xy minus xy. Then second row, second column, 2 into 4y square plus y square plus y square. Then second row, third is 2yz minus yz minus yz. Then third row, first column, 0 into z minus xz plus xz. Then third row, second column, 2yz minus yz minus yz. Then third row, third column, z square plus z square plus z square is equal to the given matrix 1 0 0 0 1 0 and 0 0 1. Now equating corresponding term here. You will get answer square plus x square is 2x square, then 0 0. Then xy minus xy 0 6y square 0 0 0 and 3z square is equal to 1 0 0 0 1 0 0 0 1. Now we are getting corresponding terms, that is 2x square is equal to 1. That implies x square is equal to 1 by 2, and therefore x is equal to plus or minus 1 by root 2. Then 6y square is equal to 1. That implies y square equal to 1 by 6, and that implies y equal to plus or minus 1 by root 6. And last 3z square equal to 1, z square equal 1, and therefore z square equal to 1 by 3. Z is equal to plus or minus 1 by root 3. It's very simple. There's only multiplication and transpose, condition for transpose. Then we get answer x, y and z. The values of x are plus or minus 1 by root 2, y plus or minus 1 by root 6, and z plus or minus 1 by root 3. Okay, that's all. Clear? Now discuss another question. I mean, special case 2. Okay. SC2 is also a miscellaneous question. SC2, special case 2. Okay. Our next question is solve matrix 1 to 1. Solve means we find any value 1 to 1 into matrix 1 to 0, 1 to 0, 2 0 1. Third row is 1 0 2 into column matrix 0 to x, 0 to x equal to 0. Okay, solve. That means we find the value of x. We find the value of x. So if you want to find, solve means you find any value. So in the case like x, the question is k or p or any value. Mixing value. That's all. Okay, we find the value of x. Okay, first of all we multiply first matrix by second. Okay, so order is 1 by 3 and this order is 3 by 3. So here number of columns and number of rows are equal, and so matrix multiplication is possible. Okay, now multiplying, and resultant matrix order is 1 by 3, so there is only one row. First row, first column, 1 into 1 is 1, plus 2 into 2 is 4, plus 1 into 1 is 1. Again, first row, second column, 1 into 2 is 2, 2 into 0 is 0, 1 into 0 is 0. First row, third column, 0 plus 2 plus 2. Okay, into column matrix 0 to x is equal to 0. Okay, now adding these matrices, we get the answer is 6 is 2 and 4 into column matrix 0 to x is equal to 0. Again, using multiplication, here the order of this first matrix 1 by 3 and is 3 by 1, and therefore number of columns and number of rows are equal, and resultant matrix order is 1 by 1. Now multiplying this matrix by this matrix is a row matrix and this is a column matrix. 6 into 0 plus 2 into 2 plus 4 into x is equal to 0. 0 means is also a singleton matrix, that is two element matrix. 0, 4, 4x. Now adding these two matrices, these two elements, 4 plus 4x, corresponding right side value is 0. Is a 1 by 1 order matrix, is also an 1 by 1 order matrix. So now equating these two matrices, because these two matrices are equal. If the two matrices are equal, their order are same, and each element of the first matrix is equal to the corresponding element of the second matrix. That is a definition for equality of two matrices. And therefore 4 plus 4x equal to 0. That implies 4x equal to minus 4. X is equal to, we get answer minus 1. And therefore we get answer x is equal to minus 1. That's all. This is also a very important question. This insert test based on extra 2 or more questions are available. Using that question we can practice it. Okay. That is SE2. Now discuss one more questions based on special problems regarding the topic matrices. Our next question is also a very important question. Our next question is that find the matrix X. Find the matrix X such that X into 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 equal to minus 7, minus 8, minus 9, 2, 4, 6. 2, 4, 6. We find matrix X. X is a matrix, not a scalar value. Scalar and okay, corresponding equity we get answer. But here there exists a matrix X. Find the matrix X. Not a X means it's not a scalar quantity. I mean it's not a particular value. We find the matrix X. Actually, this matrix. First of all, we suppose that matrix X. Suppose you take X is equal to. Suppose you take let X is equal to. Suppose you take A, B, C, D. Suppose you take matrix X is equal to A, B, C, D. What do you get A, B, C, D? First of all, you understand what is the order of that matrix X. X in the order is but X in the order is technique. Already suppose order of X suppose M by N. Order of X suppose you M by N. You already know what is the order of this matrix? 2, 3, 2 rows and 3 columns. And resultant matrix order we get again 2 by 3, 2 rows and 3 columns. Okay, you already know if a matrix here matrix multiplication already possible. Because matrix multiply we get an answer is on the right side matrix also 2 by 3 matrix. Here matrix multiplication already possible. So you know two matrices are matrix multiplication possible. You know the number of columns of first matrix and number of rows of second matrix are equal. If m by n into 2 by 3 matrices multiplication is possible because our resultant matrix is available. So here number of columns and number of rows are first matrix number of columns is equal to second matrix number of rows. That is here already we get the answer n is equal to 2. N is equal to 2. And resultant matrix order is you already know m by 3. Here already given the resultant matrix order that is also 2 by 3. And therefore now equating corresponding time we get m is equal to 2. Therefore m order is 2 and n is 2. M and n are 2. And therefore we suppose the order of the matrix X is 2 m by n, that is 2 by 2. Okay. So matrix multiplication possible first matrix number of columns is equal to second matrix number of rows. So here automatically we get n is equal to 2. And resultant matrix we get is m by 3. We already get resultant matrix, that is order is 2 by 3. That is m by 3 is also equal to 2 by 3. And therefore now we get m, we get m equal to 2. If m equal to and n equal to, and therefore our supposed matrix X matrix order is 2 by 2. Okay, that is a way of finding the order of that matrix X. Okay, we suppose our matrix order is 2 by 2 and therefore the elements of X we suppose A, B, C, D. Now we find it small a, small b, small c and small d. How to find? Here we put X corresponding, we put A, B, C, D into 1, 2, 3, 4, 5, 6 is equal to minus 7, minus 8, minus 9. Second row 2, 4, 6. Okay. Now multiplier, now using matrix multiplication, we get the answer first row, first column, that is A into 1 plus 4 into B. First row, second column, 2A plus 5B. First row, third column, 3A plus 6 into B. Then second row, first column, 1 into C plus 4 into D. Second 2C plus 5D. And last 3C plus 6 into D is equal to minus 7, minus 8, minus 9, 2, 4, 6. Here these two matrices are equal. You know the condition of equality. When two matrices are equal, their order are same and corresponding elements are equal. And therefore A plus 4B corresponding element, right side matrix element is minus 7. And 2A plus 5B corresponding right side element is minus 8. Equation number 1 and this equation number 2. Again we get 3A plus 6B is also minus 9. There two equations are enough for finding A and B. Okay, now solving these two equations we get A and B. How to solve? First of all we check your coefficient of A. Here the coefficient of A is 2 and the first equation coefficient A is 1. So first of all we multiply equation 1 by 2. And therefore 2A plus 8B is equal to minus 14 equation number 3. Now subtracting these two equations we get answer 5 minus 8 minus 3B equal to minus 8 plus 14, that is 6. and therefore B is equal to, we get answer minus 2. Okay. Now substituting the value of B in equation number 1, therefore A minus 4 into 2, that is 8, is equal to minus 7, and therefore A equal to 8 minus 7, answer is 1. Now we get in C plus 4D. C plus 4D is equal to equation number 4, and 2C plus 5D is equal to 4, equation number 5. Here also, first of all, we eliminate the C term. For eliminating, multiply equation 4 by 2, and therefore you get answer 2 into C, that is 2C, 2 into 4, 8D, equal to 2 into 2, 4, answer is equation 6. Now subtracting 5 minus 8 is minus 3D is equal to, becomes 0. Sorry, C plus 4D, and okay. And therefore D is equal to, answer is 0. D is equal to 0. And therefore now substituting the values D in equation number 4, therefore C plus 0 equal to 2, that implies C equal to, answer is 2. Here we get A, B, C, D, and therefore the recurring matrix X, that is X is equal to A corresponding value is 1, B is minus 2, C is 2, D is 0. That is the recurring matrix. Now multiply this matrix by this matrix, we get answer minus 7, minus 8, 2, 4, 6. Okay, it's a very simple, but it's a very important. So try to practice the question. Okay? So repeat once. Right? First of all, you take the order of this matrix. Using the concept of matrix multiplication, we get the order of this matrix as 2 by 2. Then we assume a 2 by 2 matrix. Suppose here we assume the 2 by 2 matrix as A, B, C, D. Now multiply A, B, C, D matrix A, B, C, D by the matrix 1, 2, 3, 4, 5, 6. Which is equating with the minus 7, minus 8, minus 9, 2, 4, 6. Now multiply, we get A into 1 plus 4 into B, A into 2 plus 5B, A into 3 plus 6B. Similarly, second row first column, second row second column, and second row third column. We get. Now equating this term, that is A plus 4B equal to minus 7, and is 2A plus 5B equal to minus 8. Solving these two equations, we get A equal to 1 and B equal to minus 2. Similarly, C plus 4D is equal to 2 and 2C plus 5D equal to 4. Solving these two equations, we get again C and D. C equal to 2 and D equal to 0. Substituting A, B, C, D to the given matrix X, we get X is equal to 1 minus 2, 2, 0. Okay, that's all today's class. Our next video, we'll discuss our next topic, next chapter, determinant. Okay, bye.